Alright, ladies and gentlemen, this is your Fundamentals of Physics quiz review video, and in this video I'm going to go over each of the different skills you're going to need to know from our first intro fundamentals unit. So we're not even doing any real physics here, we're just going over some math skills that you're going to need for the rest of the year. And if we don't have these skills down packed, then it's going to make this course hard, so let's make sure we're prepared for this. And so we're going to start with some unit conversion. Especially since we need to make sure we can convert units to our intended base unit for physics. And we start with number 1, how many millimeters are in 1 kilometer? So for this type of problem, I will let you guys use King Henry died drinking chocolate milk, or whatever phrase you've learned. But I remember from chemistry classes, we've taught you guys how to use King Henry. So that is KHD. In the middle is our base, GLM. Drinking chocolate milk, DCM. So what do these stand for? Kilo, hecto, deca, the base, deci, centi, milli. So we're going from 1 kilometer to millimeters. So we're going to go from this big K, from kilo, all the way down here to milli. And so what we're going to do, we're going to count the steps to get from K to M. So 1, 2, 3, 4, 5, 6. So we got to move our decimal place over from left to right 6 places. So we have 1 kilometer. We're going to move that decimal point from 1.0 over 6 places. 1, 2, 3, 4, 5, 6. And we're going to input zeros. 1, 2, 3, 4, 5. Additional zeros there on top of the one already put there, and we get 1, 2, 3, 4, 5, 6 zeros. Millimeters. And that's our answer. Number 2. Which of the following is the largest mass? And I'm going to tell you my strategy for this type of question. Strategy is to convert to the base number or base unit. We're going to take each of these answer choices, A, B, C, and D, and convert them to our base of grams. So 100 grams for choice A is already 100 grams in base unit. Choice B, 1,000 milligrams. Again, you could use King Henry to go from milli to your base. So if we have over here going from milli to our base, that's 1, 2, 3 places to the left. We start with our decimal point all the way at the end here, 1, 2, 3, right in between the 1 and the 0. So that's 1 gram. That's very little. So that's already small. Choice C, we have 800 centigrams. So once again, let's go back to our King Henry phrase. So we go from centi to base. 1, 2 places to the left. 1, 2 in between 8 and 0. 8 grams. That's smaller than 100. Now 5 kilograms. We go from kilo to base. That's 1, 2, 3 places to the right. We already have 5, 1, 2, 3. We add an additional 3 zeros at the end of the 5. And that's 5,000. And our answer choice is D, 5 kilograms, which is equivalent to 5,000 grams. Okay. Number 3, dimensional analysis is definitely one of the hardest skills you're required to know for this class, for sure. And honestly, I see most of the use of this for longer string of conversions. A lot of the conversions we're going to do are much shorter, so there's not much of a point to using dimensional analysis for much of this course, except I still want to assess you guys on that. So that's why it's important to learn it now, especially if some of you intend to go at higher level science. So a physics textbook is 4 centimeters thick. How many books would it take to make a stack 2 stories high? You can solve this any method you choose. You'll get points, but you won't get the full credit unless you show dimensional analysis. So in order to get all the points required, you're going to need to do dimensional analysis. And we need to start by looking at some conversion factors, looking at some conversion relationships. We start with stories, and we needed to get it to centimeters. But this is a metric estimation that I want you to remember. So stories. 1 story equals 3 meters. So check your metric estimation section for that conversion. Can we get meters to centimeters? Yes, we can. So 1 meter equals 100 centimeters. And then we can get centimeters to physics textbook. So actually, my mistake. We need to get to textbooks. So 4 centimeters equals 1 textbook. So we're going to convert from stories to textbooks. How many do we need to stack for 2 stories? And the strategy is to always start with what you're given. So 2 stories is what we're given. We're going to use each of our conversion factors to the right to set them up like fractions to multiply against 2 stories, because we're converting from stories to meters to centimeters to textbooks. Now the strategy again with dimensional analysis is to treat the units like algebraic quantities. So pretend that stories is its own quantity. 2 stories, if we want to cancel out stories, we need to multiply by stories in our conversion factor in the denominator. So story, we're going to use that conversion factor of story and meters. And then we're going to copy these numbers over from our right side conversion factors. So I'm going to write 3 meters and 1 story over here. Okay. So what I'm going to show you is that stories cancels out top and bottom, so those units are no longer there, and now we have meters. The next conversion factor we can use is 1 meter to 100 centimeters. So we're going to set it up again, keeping in mind that top and bottom, the units need to cancel out. So meters goes on the bottom, and centimeters goes on top. And we're going to copy the numbers again, 1 meter, and then 100 centimeters. Meters then cancel out. And then we're going to continue with our last conversion factor. 4 centimeters equals 1 textbook. So we're canceling out the unit of centimeters to obtain the unit of textbooks. Okay, 1 textbook. And then finally centimeters cancels out and we got textbooks as our unit. The next step is to multiply across the top and divide it by across the bottom. And we get 2 times 3 times 100 times 1 divided by 1 times 1 times 4. And I'm going to do the work over to the left side. So 600, I'll just do it over here. 600 divided by 4 equals 150 textbooks as our answer. That's dimensional analysis. Okay, number 4. What is the approximate width of a person's little finger? So if we're thinking your pinky finger, we're talking about the width of it, not the length of it. So we're not looking at the long side, we're looking at the short side of your little finger. And that's about, I'm going to approximate it as 1 centimeter in terms of metric units. 1 centimeter. Let me just rewrite that. And in terms of standard scientific notation, that's 10 to the negative 2 over meter, which is 0.01 meter. I'm going to cross off choice A because that's too big. 1 meter stick, that's a yardstick. That's too big for your pinky. And then D is also kind of too big. Too little. That's a millimeter. That's really, really, really tiny. That's not even an inch or half an inch. And so we're down to B and C. Given our conversions over here, we're going to go with choice C because that's the equivalent of a centimeter, which is closest, I would say, rather than choice B, which is 10 centimeters. Okay, number 5. All right, Mr. Garger's being a sneaky, sneaky little person trying to steal my classroom items. All right, this is the escape route. I'm going to draw it over here to the left. But first we need to keep in mind our compass directions. north, east, south, west. We're going to follow these directions. And we're going to go in order. So 30 tiles north. Going 12 east, 5 south, and then 27 west. That's kind of an approximation of what it looks like. It's not entirely accurate, but this is what our drawing is, and we're trying to figure out our resultant displacement vector, which is the hypotenuse of our triangle. Now, this looks like not exactly a straightforward right triangle. And the way we're going to do this is to simplify our vectors, especially those that are in opposite directions. We subtract, same directions, we add up. So I'm going to do that over here in the white space. So we got 30 north being opposed by 5 south. These two simplify to 25 tiles overall going north because they're opposite directions. 12 east and 27 west. Again, we take their difference. That's 15 tiles overall going west. And if I'm going to redraw it over here to the right side, that's 25 north and 15 west. And then a resultant vector always goes from start to finish. So if I went north and then west, my overall displacement is northwest. So that arrow should be pointing northwest. If you pointed the opposite direction, that's incorrect. And I won't give you that point. So make sure we follow directions of our overall path. And now we could do Pythagorean theorem. A squared plus b squared equals c squared. 25 tiles. Make sure you show units, guys. Squared plus 15 tiles squared equals c squared. And if you do the math, your resultant vector should come out to about 29.2 tiles northwest. And now we're down to the final 3 questions. These take a little bit longer because we got more calculations here. But anyway, let's start with vector components, question number 6. So vector components is when now you have your resultant vector and a given angle at which it's projected. And you have a speed of 8 meters per second, so that represents your vector quantity. And we need to figure out the horizontal component and the vertical component, AY. And we just need to calculate it. So AX equals A cosine theta, and AY equals A sine theta. This is always the case. This is on your reference table. AX equals 8 meters per second cosine 27. If you show your work just like this, I'll give you full credit because you need to show work with your units. The only difference between these two components is just using sine and cosine. The setup is entirely the same. The numbers are in the same positions. You're just changing sine or cosine. Okay. You get your horizontal x component to be 7.13 meters per second and AY to be 3.63 meters per second. And that's it for number 6. You just need to know how to calculate vector components. In terms of conceptual trends, we're not going to focus on that till later. All right, number 7. Determine the slope of the graph to the right. So here you have a graph that's linear, and in order to calculate for slope, here's your equation. Slope is change in y over change in x, or y2 minus y1 over x2 minus x1, rise over run. Okay. First, before you even calculate, you need to identify 2 points. 2 very clear and obvious points you can use that are on the line. As long as you're able to approximate as best as you can and do the correct process, the numbers might be slightly off, but as long as you get something that's within acceptable range, you'll get the credit. Because at least you're showing you know how to do this. And don't forget to show your work, so you substitute values in. This point over here, closer to the top, that's a point of 3.8. And then the one closer in the middle is 1.54. So we're going to do the y's first. So 8 meters per second minus 4 meters per second divided by 3 seconds minus 1.5 seconds. That's a difference of 4 divided by 1.5. And you get that your slope value is approximately 2.67 meters per second squared, because I'm just taking the units of my x and y and mashing them together. Okay. Alright, that's it for number 7. Number 8, the equation for the kinetic energy of a given mass is represented by Ke equals 1/2 mv squared. Identify the relationship and sketch the graph for each of them. So we got part A and part B, and we're focusing for part A of kinetic energy and mass. So again, my strategy that I showed you in class is to change each of these second variables into x, so we can compare it to our known graph relationships. So for part A, we're focusing on mass. So I'm going to change m into x. And then, given that we could see what x is, we know that x has no exponent, and it's in the numerator. So based on those traits, y equals x, that's linear. Not only do you have to identify the relationship, you need to know the shape. So linear is a straight line. Part B, we're going to start the equation over from scratch. Replace v now, because we're focusing on velocity. V is going to be x. So 1/2 mx squared. Let's analyze x now. Now there is an exponent. There is an exponent. It's still in the numerator. We don't see any fraction line, all of these in the bottom. So now, this is going to be a different type than part A. Because there's an exponent and it's in the numerator, this is what we call quadratic. Y equals x squared. So it looks like a parabola. Just need to sketch it like that. And that's it.